Who am I looking for? How's it going? Good to see you. How's it going? Both are good. All right. Good morning, everybody. Good morning, GrrCON. Come on. Woo. I want to thank everybody who makes GrrCON possible. It's a wonderful community event, one that I've been coming to for a number of years, and one of my favorite conferences to go to. But I appreciate you coming out here today to hear me talk about baselining behavioral tradecraft. I think this is going to be a fun talk. This is the very first time I've ever given this talk. I've been working on it now for the past couple of weeks, writing some new code and some awesome stuff out there, coming up with some new ideas. So I think it'll be fun, and we'll kick it off. Just a brief introduction of myself. I'm Dave Kenendy, founder and CEO of TrustedSec and Binary Defense. TrustedSec is an information security consulting company. We have folks all over the world, including Norway and the UK and a lot of other places. And we focus primarily on everything from adversary simulation, penetration testing, red teaming, application security, all the way to GRC work, PCI work, risk assessments, and building out security programs. And then Binary Defense, which is a 24/7 security operations center where we focus on identifying indicators in your environment. But prior to that, I was the chief security officer for Diebold. I ran the security program for a number of years. I always throw the caveat that I came in after the voting machine issues that they had found, so I just want to make sure that that's clear. But prior to that as well, I was working for the United States military. I was in the Marines, way better than any other branch out there, by the way. I saw the Navy one hat there, so just messing with you. And so I was in the intelligence community, working for a number of different agencies there, spent 2 tours in Iraq, and I've been very fortunate in the security industry. A lot of my tools became very popular, the Social Engineer Toolkit, Magic Unicorn. I wrote the book, co-authored the book, Metasploit, the Penetration Tester's Guide, which I just found out, we just broke our 45,000 copy mark, which I thought was really awesome, so yeah. And interesting enough, I've testified in front of Congress, and I've also been in a Chris Brown rap video, which I thought was always really interesting. Literally, I'm just bobbing my head and hacking on a computer, and there's a bunch of dancers doing flips and stuff behind me. It was really weird, actually. So I don't recommend being in a rap video or any music video. I don't think they portray hackers really well, but we'll see. And I also help out with the TV show Mr. Robot. So just that's a brief introduction. So why are we here today? This concept really came off of defense is getting better. And so defense is getting better in most organizations, and not every organization, by the way, but most organizations are really trying to step up what they're doing from a detection standpoint. I think as an industry, we've recognized that we no longer have a castle mentality of protecting our infrastructure or our data in a way, because everything is kind of fluid, right? We have our cloud infrastructure, we have BYOD, we have mobile devices, we have all these different things. We have technology changing at a different rate every single time. And would anybody here say that you know every single piece of technology in your enterprise? And we laugh at that, right? Because it's not possible. So there are exposures that we know that are in our environment that are unknown. There are attackers that can exploit those weaknesses that we know that are unknowns. And so we no longer have a way to prevent our enterprise in a 100% fashion. We never really did. It was never really possible to do something like that. But at least we tried with a lot of the draconian firewall rules that we used to make, and holding up everything that we used to do. But really things have changed. And what our focus now is around detecting things earlier on and trying to prevent and minimize the damage towards an organization, as well as try to implement as much prevention as we can. I always say that prevention takes a long time to implement in a company. There's no way to implement application whitelisting in high integrity mode overnight, right? It just doesn't happen overnight. It takes time to build protection in our environment. And so how do we augment ourselves in a way to get better? And the question, and the answer to that is, we focus on what we call the tactics, techniques, and procedures of attackers, or the TTPs. And it's a big buzzword in the security industry. But what's interesting is that we've really focused on the techniques aspect of the attack chain of what we see across attackers. And there was a great talk by Jeff Moss a couple of years ago, right before he introduced the keynote over at Black Hat. And he said, as an industry, we talk about the tactics, techniques, and procedures of attackers, but as an industry, we're solely focusing on the techniques that the attackers exhibit. And that's very true. You look at a lot of the new EDR products that are out there today. They'll grab Cobalt Strike, or they'll grab Empire, or they'll grab Metasploit, and they'll build detections off of those tools, right? And so if a commodity type hacker that doesn't change or craft or code in some way, shape, or form uses that type of tool in your environment, you should get an alarm or have some sort of information on there. But if you modify it in some way, you usually go unnoticed. And so we'll talk a little about what that means. So as a industry, we have gotten better at detecting specific attacks. So what's the next evolution? What are we going to see next? So my goals for today is that how playing defense can raise the bar in detection and specific attack patterns. Show how easy it is to still bypass detection techniques today, and even preventative mechanisms today. But ultimately, providing some red team some good stuff to use in their next engagement. So I'll be releasing some stuff here today for you. And then how to best defend against the next wave of attacks that we have out there. And again, I think it's really important to have that red versus blue mentality, because red should be just a little bit higher than your defense, and continuously trying to raise that bar, working back and forth. So if you look at the industry today, I thought this was an amazing picture, but the industry today is really based off of crowdsourced techniques. A new researcher comes out with a way to use a living off the land binary and script. In fact, I think Hex just came out with one today using a specific tool. It was obfc-conf.exe, I think, was a new living off land binaries and scripts that you can do basically the same type of technique as run DLL32. And so you look at new techniques that come out every day. You have a research industry which is publishing tools, or publishing techniques, or publishing new ways to get code execution onto systems. You have the open source community, which focuses on maintaining tools that we can use to simulate attackers in our environments. And then you have threat intelligence, which your biggest source is Twitter, and you're using that information to build capabilities in your environment. So we have crowdsourced techniques in our environment. Our defenses today are really built off of what we see and the tools that we detect. Again, a new tool comes out at DEF CON. All of these security researchers at the different companies that have EDR products and antivirus products, like, we need to get this detection in and build it really quickly into our environment so we can detect this new hacker tool that's out there. Interesting enough, I wrote a tool called Magic Unicorn, which was an exploitation framework for PowerShell. And the way that it would work is it would use what's called a syswall64 downgrade attack, which I came out with it 7-8 years ago now, I think, to this day. And so 7 years ago, I released Magic Unicorn. And what was interesting about that is the way that I did it is I used a technique that Matthew Graeber identified through leveraging PowerShell to inject shellcode directly into memory through that current process. And what I was able to do is take shellcode that is native on 32 and 64-bit shellcode and downgrade that process. If I'm in a 64-bit Windows platform, I can use native 32-bit shellcode on that operating system. And this technique worked for about 5.5 years. No changes, modifications, or anything crazy they needed to do. 5.5 years until it got really popular, and then what happened? Oh, I need to start writing detections for this because it's really popular, right? I need to start writing ways to detect this because it's really, really popular. And so I started making changes to it, and a funny story is Windows Defender really, really took a liking to me. And so I would come up with a new bypass technique, and they were leveraging AMSI, if you're not familiar, the anti-malware scan interface, which does a lot of scripting languages like PowerShell, for example. And you could basically, there's what's called AMSI scan string and AMSI scan buffer, and you can basically scan that specific code that's about to run in the PowerShell interpreter right before it's about to execute. So basically in its most decoded sense possible. And so what was interesting is that they're running me through AMSI, and they'd write new signatures almost every week for me. So I would write a bypass technique, they would write a new signature. I would write a bypass technique, they would write a new signature. And this went on for about a month, and then finally I got pissed. And I'm like, you're not fixing the issue of why this is possible. You're not fixing that you can do code injection through PowerShell to get remote code execution through your scripting language. That's where your focus should be on. So what I did is I basically wrote a program that understands PowerShell syntax and understands Python syntax. And so what would happen is it'd submit to my local Windows 10 machine. It would go and get the latest updates from Microsoft, and it would test to see whether or not Unicorn got detected. And if it would automatically rewrite Unicorn to bypass it. And then it would automatically submit a pull request for me. So literally within 30 seconds of a new Windows signature coming up, it would have a new bypass technique basically built in. And so this went on for about 3 weeks, and then finally they gave up. So why I say that is our defenses today are built off of the tools that we see. Interesting enough, a funny story about that is right when I was writing GrrCON, I was working on a couple different ways to get code execution within PowerShell, okay? And so one of the tools that I wrote 7 years ago. I never published because it was kind of like strung together code. It didn't work really well, and the Unicorn tool worked really effective. This one worked great though, and I never published it. When I run it today, guess what happens? Nothing. Not a damn thing. So our detections today, our defenses today are really built off of tools that we release. And the tools that we use to detect these attacks are built off of things that are published, right? They're not built off of baselining or looking at unusual behavior in our environment. That comes from people. And so really when we're going to start talking about baselining Tradecraft, if I start to build something out that looks believable, what's going to happen? I'm going to circumvent your tools because it's not published. And 2, I'm going to circumvent your analysts because it looks legit. So I'm going to show you a demonstration here of our current state of security today, okay? And what's interesting about this is I'm going to use a technique called living off the land binaries and scripts. If you're not familiar with that, if you look at traditional ways to get code execution into systems, if you look at 10 years ago, what we used to do in hacking is we would assume that they had Java installed, we'd assume they have Adobe installed, we'd assume they'd have Office installed, and we'd come up with an exploit that could get code execution, or we'd use a Java applet, or we'd use an Excel macro, which, by the way, Excel macros still work beautiful today. Has anybody here been able to disallow, ban all macros in your environment? Don't have one hand. I wish. I want to find that one person because I want to give a round of applause. Like, it'd be amazing. But macros still work amazing, right? And so you have code execution through those ways. We would assume that those applications would be installed on a victim machine that we're going after from an attack or a social engineering perspective or a phishing campaign. And so the new way to kind of hack, which is the cool way, is you take basically Windows binaries that we know 100% if we're targeting Windows are going to be on the operating system. And there's about 77 of these total binaries and scripts that are on Windows platforms, and they're code signed by Windows. So they're legit applications through Windows, right? So if you log in your computer, what? Explorer.exe spawns, lsats.exe spawns, winlogin.exe spawns, all these processes that make the operating system work, right? Calculator, code signed by Microsoft, is an application that is built into the operating system, right? You can uninstall it. Interesting enough, there's a lot of these binaries, though, that are code signed by Microsoft that have additional functionality in them that allow for remote code execution. One of my favorite ones that I'd like to pick on is Registry R32. It's under the Systems32 directory, and it's by default on every single person's Windows machine. It has its own built-in browser. It's proxy aware, and you can download any code from the internet and have it automatically execute. So you can download Scriptlet Objects, and then to give you full remote code execution onto the system itself. There's a whole bunch of these, by the way. There's cbd.exe, csc.exe, mavinject, a whole bunch of these that we can use for remote code execution, okay? And so what we do is we get command execution onto a system. That could be through a macro, and all we're going to do is initiate one command. Now, when we initiate that one command, that command typically isn't malicious. It's just going and downloading something directly from the internet and executing it into the system without having to download a binary, without having to use PowerShell, which our defenders are typically looking for. We're basically using remote code execution functionality through one command line. So it's a phenomenal way to get remote code execution into systems, and most people aren't looking for these types of techniques. So I'm going to do an example here, and I'm going to show you Registry R32 as an example. Registry R32, again, in your System32 directory, browserware. Now what we're going to do is we're going to do a little bit of a spin on it, though, to get remote code execution. So let me get into my Windows machine. Now, funny story, right before I started the talk, my Windows machine went to go update. So I think it's done, and it's done. So thank God. I was actually really sweating it a little bit earlier. And so what we're going to do here, let me just show you an example of what a Scriptlet object looks like here. And all we're going to do for our proof of concept is just call an ActiveX object called wscript.shell, and then we're going to run calc.exe, okay? Calc.exe, the notorious way to show that you have code execution at the system, right? It's nothing cool and exciting. It just pops up to show you that we can execute anything that we want to in the system. And then what we're going to do is we're going to execute this next command here. Now this command right here is, if you Google that command, it's like a lot of malware uses this specific one to deploy ransomware. You'll see this commonly used by adversaries all the time. And this is a malicious command, right? And if you look at baselining your operating system, this command is never used. /I going to a website is never, ever, 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 ever used in your environment. Ever. So there's no reason why Registry R32.exe should have the ability to go out and be proxy aware, to go out to the internet and download code and automatically execute direct objects into there. So if I go and execute this commodity Googled attack, what happens when I run this commodity Google attack, this living upland binaries and scripts on a Windows machine, running the latest and greatest version of Windows Defender. So I run this, watch what happens. Uh-oh, access is denied. So let me explain something here real quick. Think about this. Instead of removing the functionality in Registry R32 that's malicious, i.e. the /i going out to an HTTP site, they wrote a signature to look for HTTP inside of a /i command. Let that sink in for a second on the attack surface on Windows. So instead of removing the functionality, they write a signature to disallow it. And by the way, this isn't even going out and downloading anything. It doesn't even execute the downloader. So it's not going out and inspecting that test.txt. It's just saying if I see a Registry R32.exe go out via an HTTP site, I'm going to trigger a virus alert. Okay? So what happens if we use Registry R32 and we change our command just a little bit to see what happens? There are ways inside Windows to download files all over the place. There's a million different ways to, through the command line to download files directly from the internet. Is everybody aware of those, right? You can use PowerShell, for example, but we don't want to use PowerShell because as a defender, you're looking for PowerShell, aren't you? So we have to use other out-of-the-box methods to download the code that we need, and just a text file, by the way, it's test.txt. We can name it whatever we want to, right? If I'm trying to tell a story here to be believable, what am I going to use? I'll use github.com readme.md or readme.txt. As a defender, are you going to think that's malicious? No. So there are many ways for us to go and download code from the internet. By the way, you can use excel.exe. If you type excel.exe space http:// and go to github.com and do a download excel.xls, it'll actually download that file and store it in the temp directory for you. There are many ways to download code directly from the internet through the command line itself. So let's modify our command in a way. And what we're going to do here, let me get rid of this one here. And what we're going to do here, by the way, there's also another bypass technique I'll show you really quick. So what the defender signature actually looks at is /i HTTP going out to a website and using the scr obj.dll. What happens if we rename scr or copy the file scr obj.dll to something different? Easy peasy, right? That's the defender signature. The next thing we do, though, if we don't want to rename DLLs, which again are code signed, so no biggie. So they're code signed, they're legit. We can rename it, we can execute it, we can get full and row code execution into the system just by renaming that specific instance there. Again, that's the defense of today. Or let's just go and download something. We use bitsadmin to download a text file. Bitsadmin will go and download this file for us. And then what we're going to do, notice here we're calling in the same command, and registry R32.exe /s/u/s/, well, there's an n in there, so you can put the n in there. I didn't put the n, just to display it. And then /i, and then we're just going to load this text file, test.txt, and call Scriptlet Object. Now, again, we're not using HTTP anymore. We're just going directly to test.txt. This can't work, right? It does. So let me get my IP address really quick. 221.142.221.142. And I'm going to copy this command here. And all I'm going to do on my Linux machine is in here, I have test.txt. And by the way, I use Nano, best editor ever. VI sucks. Oh, I'm just kidding. Oh, some people actually just got up and left. Oh my God. I'm just kidding. It was a joke. Just go. Nano is far superior though. But so you go to test.txt, and in here you can see we have our wscript.shell running calc.exe. So this is the same scriptlet object that I just showed you just a second ago that it will be going and executing. Okay. So what I'm going to do here is I'm just going to create a simple HTTP server out of Python, and this will share out my directory. So anything that's in this directory, I'll have directory browsing in here that you can go and see. Then over here, we'll go ahead and run this specific command that we said before. And again, we're going to execute the test.txt from that IP address, and then execute, and hopefully we see calc.exe. There we go. And so we circumvent the amazing Windows Defender signatures that are signatures. So the problem that we face today as attackers is that commoditized attacks will get detected. So they go and they download the commoditized attacks and they write signatures for them. Every EDR product works the same way, by the way. An EDR product looks for Registry R32 going out to the internet. What happens if you never call Registry R32? It doesn't have the connections to it. Another good example that Daniel Bohannon from FireEye and the Flare team identified that he saw was there's a lot of detections around PowerShell, especially if PowerShell is communicating out to the internet. There was an adversary that used CertUtil, which if you're familiar with CertUtil, it's a way to import and export certificates. CertUtil also has the ability to download code directly from the internet. Why? Don't know why. But CertUtil, you can directly download any file you want to from the internet. What they were doing, what the adversaries were doing, we were downloading PowerShell directly from the internet and executing PowerShell without ever triggering network communications. So your detections started to go out the window then. So a lot of ways to circumvent things today if you just think a little bit out of the box. So you have a higher probability of detection for the things that we use more often. It's the same thing as if we sent a fish to 300 people. A funny story, I was doing a pen test for a manufacturing company, and they're in business for, let's just say, 50 years, okay? And it was around the same time as the iPhone 11s. So, you know, the nice nifty iPhone 11s, everybody wants to get an iPhone 11. And I sent a pretext to 2 people inside the organization. The first, well, it was 3 people total. So the first person I sent the phishing email to was the corporate communications person. And I said I wanted to do a story on them about how awesome their company is, being, you know, an American-based company in 50 years and also their stuff manufacturing. And they were like, oh my gosh, I'm so excited to do this story. And all I was trying to do is I wasn't phishing this individual person from corporate comms. I just wanted to know what their emails look like. You know, the template that they use, the fonts, the disclaimers, the warning banners, everything else that I could see from this manufacturing company. I just wanted to see that email. And then I targeted 2 people, one in R&D and one in IT. And basically the pretext was from that corporate communications person, saying that, that we're so excited about our 50-year anniversary of being in business. We're going to be giving away, raffling off 50 free iPhones to the IT department and the research and development department because you 2 were randomly selected for being the most amazing groups in our organization. And so it worked immediately. I got 2 shells. Got 2 usernames and passwords also submitted because we had to verify their machine and all this other stuff, right? And then when we did that, what was interesting though is I had 2 people, and I'm like, everything's great. I just hacked the heck out of this company. I got the R&D person that has all the data I need. It's like a lazy day for me, right? I can go, pack up early and start writing the report. And all of a sudden, I started getting a whole bunch of more shells. It's like shell, passwords, usernames, passwords, and it's just flooded like crazy. I'm like, what in the hell is going on? I only sent it to 2 people. Well, they started forwarding it to their friends. And their friends started submitting. And it kept going and it blew up so large that the corporate communications person got wind of it and it shut down our entire attack. So I lost all my shells, lost everything. Now, funny story about that one. My favorite part about it is the next day, I'm like trying to build out this new pretext. I have to go do all my work again. It's going to be a rough week for me, right? And what they did is they blocked the command and control infrastructure. They blocked the website that was malicious, but they didn't block the email address that it got originally sent from. And so I had a person in IT say, one of the stupid people in security blocked all the stuff to get my iPhone. Can I still get the iPhone? And I just responded back to him. I said, sure, just go over to this new site over here. And I was all set. I was back in. It was really easy. It's amazing. So when we talk about detections, phishing and hacking are very much the same thing, right? When we do phishing, what do? We're telling a story, aren't we? We're telling a story to that person that they have to believe. We're creating a fantasy world of knights and everything else, drawbridges and castles, this fantasy world that we're creating, they have to believe it. In hacking, it's the same thing. If I send an email to 300 people, what's my probability of being detected? Pretty high. If I send it to 1 person, what's my probability of being detected? Especially if I customize that one attack off of that person, what's my probability of being detected? Substantially lower. Not perfect, but it's substantially lower, right? So I'll throw this out there, is that if we change our story that we're telling the computer, and we change our story that we're telling the people, our detection rates substantially go down significantly. Commoditized malware and organized crime is really where our focus is at in the security industry. That's really where we focus most of our efforts. We're not focusing on adversaries. We do to some extent when we get a new data breach dumper. They finally got detected after like 7 years. Did you see the iPhone one where it was up on a website for 3 years where they're running iPhone 0 days. They can own any iPhone that browsed that website? We learn after the fact, right? We learn after the fact that somebody's been in our environment for 2 years, for 3 years, for 5 years, or it happened to somebody else. We get a new technique and all of a sudden we build our detections off of that. That's this industry. While adversaries will use common tools and research topics because that's easy, why burn a 0-day? Why burn a new technique? Why burn a story when I can just use something off of the internet that's going to work 90% of the time because most companies still don't do a decent job with it? Now again, we're getting better at defense, but why not use a new technique? A new technique, what's the shelf life on a new technique? Anybody have any idea on average? Several months to years, usually, right? So a good example, everybody remember the DD Auto one that happened a couple years ago? So there was in Excel, you have macros, right? And macros are used very commonly for remote code execution. There was a researcher that made a blog post about how you can get remote code execution within Excel without ever using macros. It was called DD Auto. It was a flag within Excel. Now, Microsoft at the time said they were not going to fix it. They submitted it to Microsoft. Microsoft said, we don't see this as a security issue. Remote code execution without using macros, we see this as a feature. Cool. All right, fine. So those are the best ones, by the way. When we have a feature like MSHCA.exe or Registry R32.exe or all of these other ones, the shelf life for these attacks are so much longer. They last so much more than an exploit that gets patched in 1 month or 2 months or 3 months. And so with this specific one in DD Auto, as an attacker, if I see Microsoft is not going to patch, and I can get remote code execution through any Excel document, what happens? They use that technique immediately. And so what's interesting is that within 4 hours, it was being used in the wild. 4 hours. Did anybody here have a detection within 4 hours in the environment? Did anybody here run a registry change across their entire environment to get detections on this one or to be able to prevent it across their entire enterprise without testing? No. So our lifetime for new attack vectors are pretty substantial. So when adversaries play in this space, of course they're going to use common tools. Of course they're going to use research topics that get published. But they can customize their attacks anytime. If you look at ransomware authors, usually there's probably 20 to 30 people in those groups. And what's interesting is they have these highly skilled attackers, and then they have these kind of weak attackers that go and do the actual hacking into companies, right? They do the phishing campaigns, and then you have the malware developers that are actually developing the malware itself. And most of the malware isn't super sophisticated, even though the people that are actually writing the malware might be, because most of the stuff works on 99% of the companies that they go after. Why change to something else? What I found that was funny is if you look at Fin7, financially motivated organization or organized crime, I thought what was really funny with them is they came out with a 0-day. They found a 0-day in rich text format browser, so RTF documents, okay? And what was interesting about that one is that they had a 0-day to get remote code execution that no one was detecting, 0 people. What did they do with that 0-day? They used it, but what did it do? What was the actual behavior that they used? It went and downloaded an executable. Because executables worked on 99% of their companies. They didn't have to stay in memory. They didn't have to do anything else. They just used the 0-day for almost a year without detection by going and downloading executables. Crazy. As an attacker, you should get caught with out-of-the-box stuff. If I'm using PowerShell to use encoded command or invoke expression, I should be caught as an attacker. Those are common things that we should be detecting in our environment. In your environment, is invoke expression and encoded command used consistently across the board, across all of your developers? No. Now, is it used sometimes? Sure. Can we baseline that traffic and say, okay, this is baseline traffic. We know this is legit. Let's look for unusual patterns in our environment. Yes. So if we're logging PowerShell, and if we're looking at something like script block logging, or we're looking at any type of EDR product that pulls PowerShell stuff, we should see things like this that look malicious. We should see that stuff. It's commodity attack vectors using commodity ways to go after an organization. So I'm going to do another demonstration, and again, I'm going to pick on Windows Defender. Nothing personal. It's just one of those ones where this is the tit for tat that we were going through, or this is how hard it was for me to circumvent Windows Defender. So what I'm going to do here is I'm going to use Unicorn, and so on the left-hand side here, you can see my Unicorn script I'm about to run. And Unicorn is an open source framework. And what we're going to do is we're going to generate a Windows Interpreter shell, which should be caught by traditional antivirus, right? Windows Interpreter out of the box without any changes should be identified pretty quickly. So we'll go ahead and run this. And what I'm going to do is I'm just going to decode this data really quick so that we're only focusing on the raw code that's going to be executing the shell code itself, the obfuscated shell code that's going to be running on the system itself. And when we run this, we're just going to get our code out here. This is our encoded code that's our decoded code, but it's still obfuscated. And what I'm going to do is I'm going to paste it over here into the PowerShell interpreter. And what's going to happen is I'm also going to create a listener at the same time to catch my shell if I'm successful in bypassing Windows Defender. So I'm going to create a shell within Metasploit. I'm going to do MSF console-R, use a resource script to grab that. And then on the right-hand side, I'm going to hit play. Now notice here when I hit play, I get a antivirus has blocked it. And this is, and I'm going to take a pause here for a second. So right now, what's happening is that AMSI, the antivirus scan interface, is decoding my code and submitting that raw code directly to Windows Defender. Windows Defender then uses AMSI scan string or AMSI scan buffer, which in this case would be AMSI scan string, to scan the contents of this file. And they have a signature in there directly off of Unicorn that they're looking for in my environment. What I'm going to do here, in this next second here, is notice I broke out the very last command. It might be kind of hard to see from a long piece, but what this command is, this is IEX space, and then I have a variable name, which has my encoded command in there, and then it says no exit, because I don't want the shell to exit, and then I'm going to pass that code directly to it. So I'm using invoke expression, or IEX. So what I'm going to do is I'm going to take this last command, and I'm just going to delete it, and then I'm going to hit play again to see whether or not antivirus picks up on this. So if I delete this, and I hit play, notice we don't get a antivirus detection. So something in that command is triggering the file itself. So what happens, and before I run this, I'm going to show you really quick what I'm doing. Oh, I did not want to do that. Hang on, I just clicked the wrong way. There we go. So what I have here, what I've done, is I just chunked up the IEX command. So what I said is instead of IEX calling the encoded command all in one command, I'm just going to say A equals, take my command, and I'm going to say IEX plus A. So I'm just taking the command and moving it to two commands. 1 to 2. Now if I hit play, let's see what happens. I'll go over on the left-hand side, we get our shell. Full code execution and circumventing the detection criteria for that specific product, right? So again, interesting enough. Going the wrong way. So when I talk about moving to legitimate behavior, what I'm talking about is that commodity attacks that we know today are starting to get detected more. Actually, I was at a customer recently, and one of our team was doing a red team exercise. And one of our red teamers that was working on this engagement had this amazing, we have a research division where we find some really cool stuff, right? And so we do zero-day research, we do techniques and things like that for our higher-end customers that have great security programs. We were going into a customer that had a really great security program. Commodity-type attacks weren't going to work. And so we had this super secret command and control infrastructure that we built from scratch over the past 3 years, and we get full remote code execution onto this box using undocumented features, zero-day type stuff, and again, no detections whatsoever, zero, completely silent. And they're running the latest and greatest EDRs and everything else out there, looking at parent-child process relationships and markup chaining. We went completely undetected. Awesome, right? As a red teamer, you're like, this is really cool. You know, we just circumvented this company's detections. What was interesting is 7 minutes later, we got shut down. And I was like, how is that even possible? The reason why we developed this stuff is that we go undetected in their environment. How did we get shut down in 7 minutes? 7 minutes. We spent like 5 weeks preparing for this attack. And in 7 minutes, we were dead in the water. And what was interesting is that we found out is that this customer, they baselined their employees into 2 categories. One, technical users. So people in IT, developers, things like that. The second category, non-technical, HR, marketing, sales. Well, we targeted somebody that was in the non-technical branch, and just by issuing we didn't drop into a command shell. We never do a command shell. But we typed in an ipconfig to see what network we were on. And they had baselined what technical commands were, and ipconfig was one of those. And they said that Bob and sales should never be issuing an ipconfig. And we got busted. That sucked. Really sucked. And so we talk about telling a story for companies that are starting to go above the commodity threats, where they have threat hunters that are actively looking for unusual behavior environments. We have to change our tune of what we're telling the story to these analysts, because the tools aren't going to stop us. We know that we can circumvent any tool that's out there today without any type of pain or effort. But can we trick an analyst? If that data is going back to an analyst, if you have a team that's actually looking at, instead of looking at alarms that come in from your SIM, alarm comes in, look at it, close it out, false positive, come in, false positive, come in, false positive, oh, we have one. The reactionary cycles that we have, we're not getting detected by that, and we have people that are actually combing through command line arguments. We're looking for new services that are being created. We're looking for DNS, east to west, north to south. We're looking at all these different things in our environment that we're looking for unusual indicators. The story that we have to tell that company as a hacker is much different. We have to change our tune of how we're doing things. If we're throwing out unicorn across our environment, it's heavily obfuscated code, it's gonna get detected, right? People are gonna see those types of commands even if it circumvents the technology. So let's take Registry R32, and I talked about this before, right? It's one of the most abused living off land binaries and scripts. And again, when using the /i HTTP, it'll pretty much trigger any EDR platform that's out there if they're good. But if we know that an analyst is going to get an alarm if we execute Registry R32, what can we do? Again, think about this from an attacker's mindset, like social engineering. The story that we're going to tell them has to be different than what they're told that an attacker does. So if we're looking at Registry R32 as a primary example of this, and an analyst is going to get, a threat hunter is going to see Registry R32 being executed, can we do something different to change their mind to say that this is not malicious? And I would argue here, is anybody here not busy? Does anybody here have plenty of resources for their IT security department? They don't need any more. Everything's good. No, we're all busy, right? And if threat hunters could just sit down every day and their entire job was threat hunting, it'd probably be awesome. But nobody here, I'm sure, has meetings. I'm sure you don't have all these different things that you have to do, new technology that you're building in. You're not the subject matter expert for the detection team. I'm sure you're not doing all of that responsibility as a threat hunter. So you're busy. And you only have a certain amount of time to comb through a substantial amount of data in your environment. So if the story that we tell an analyst is better than a basic Google search, then we're probably going to go undetected in their environment. And here's an example of using that. Here's an attack path that works for me. Use excel.exe to download an Excel file. What it will look like in the logs is that somebody opened up an Excel file from a website. Okay? So we go to a fake site that has a high reputation, or hosted on GitHub, or whatever you want to do. It could be a tutorial for an open source tool that you use in that company. And by the way, let's just say it's you're targeting somebody in IT, and you know for a fact that based on their external perimeter, they use certain types of applications hosted on those sites. Hosted on sites that are from those open source platforms that have GitHub pages. So use excel.exe, go to a fake site, have it download an Excel document. That Excel document is not an Excel document. That Excel document is a Scriptlet object. Okay? Excel will save that file to a temp directory. That XLS is in that Scriptlet object. Wait on the system for delay. So I would wait maybe like a couple hours or so because you don't want the alarms to come up sequentially when things are going through. So give it some time, and you're probably not going to see an alarm for this. But again, we're being super careful because we're telling a story. We're telling the analyst a story here. And so we use this XLS, which is a Scriptlet object. We rename scr.obj.dll to schmmgmt.dll, which is for schema admins for Active Directory. Okay? So we're going to rename Scriptlet object to that specific DLL. And then we're going to rename company name report _ metrics version 2.xls, which we downloaded from here, to DLL uninstall. And then we're going to call registr32.exe /s/u/i DLL uninstall schema management.dll. What's the story I'm telling somebody there? If you Google Registry R32, DLL uninstall, and schmmgmt.dll, guess what happens? Guess what you see? The tech article of why that's legitimate for Microsoft. So here we can see /i is commonly used with DLL uninstall, and you can see here an example of Registry R32 being used by schema management. As an analyst and you see that alarm come up, what happens? You Google it. The first hit on Google is Microsoft Doc. You look at that. And what happens? The story I just told you is pretty damn believable, isn't it? So as an attacker, spending some time to build a story can make you successful in pretty much everything that you're doing. If you're using Excel with XLSMs macros, make it a document with pretty graphs and data specific that use those macros. The data is actually derived from the macros itself. And guess what? You tuck your malicious code as a one-liner living off the binary script in that execution in there in a 700-page macro that is basically pulling metrics data for graphs. Is anybody going to go through all 700 of those lines in your environment? No. A good starting point, go to the site, go to a company, and do site targetcompany.com. This is some easy Google hacking. And then in URL, XLS. So let's say I'm targeting trustedsec.com or TrustedSec. I do company name. I do the company name or site equals TrustedSec, and then I do in URL and I do XLS. Does that company have any XLS files that they expose on the internet that I can use as a base template for something that is legitimate in their environment? Again, the story that I'm telling. Another example of going after SOC analysts is fighting noise. Does anybody here not have to fight noise in their environment? There are so many false positives that we have to deal with. I would say 99% of SOC alarms that come in through the SOC are false positives. So take noise and use that to your advantage. Office 365 PowerShell scripts in your environment are the most noisiest things in the world. Take that Office 365 script, which is not code signed, by the way, which is like 2,000 pages of PowerShell, and use one line for your code execution. Is somebody going to go through that Office 365 PowerShell script as it executes and not have one line checked? No. So use noise in an environment that you know is going to be noisy. Chrome updaters. Under the temp directories, the CR underscore, the randomized name. You have so many different variations of ways that we can tell a story in an environment for something that isn't legitimate. As long as we use noise to our advantage, we can trigger as many alarms as we want to. So this will always work, and it has worked for me on a number of occasions. When I go into companies, if I tell the story in a way that looks legitimate and I'm telling the story to the analyst, I can get away with an alarm. I don't have to worry about an alarm being triggered because I'm telling the story. If I'm targeting marketing, I shouldn't be running an IP config. If I'm targeting marketing and I have a marketing document that does code execution, but it looks legitimate, I'm telling that story right. Assume the roles that you're targeting, assume the people that you're targeting, assume the behavior that you're targeting on that environment and tell that story. So that means that analysts are fighting alarms when they have to make quick decisions. As I mentioned before, quick decisions are part of our job. We have to determine very quickly, and that's why if you look at like SOAR, for example, security, orchestration, automation, and response, right? It's a big buzzword in this industry right now. And the whole purpose of SOAR is to get multiple tools to combine all of your information that you can respond much more effectively to an incident. So instead of having to go to your Carbon Black instance or your this specific tool, this specific, you can have it all centralized in the SIM, so you can see all the data right there for your analyst to be able to make a determination of. So if you know that there's a lot of information that's going to be sent to an analyst, again, that story that you tell, and they have to click through things very quickly with information. If they're seeing that information, there's a lot of information, a lot of data, and 90% of that looks legit, it's going to be legit. This can be used in every phase of an attack. This can be used in the reconnaissance phase. This can be used in the exploitation phase. This can be used in the privilege escalation phase, the persistence methods, lateral movement, you name it. We can literally do this in every phase of the attack. A good example is scheduled tasks, commonly viewed from an EDR product, right? What if we make one called Office Auto or Office Click or Office Features? We make the very specific ones that are already in our environment that we know are going to be there that create a lot of noise. OneDrive, my favorite. Teams that they just added, this automatically starts up, which everybody started freaking out in companies over because it just randomly started popping up when you did an update, right? Teams is another great example. If we make them look believable, it will work. Interesting enough, Casey Smith said something yesterday, which I thought was really funny. He's like, this might be dumb, but did you know you could do C:\/ program files in parentheses x86, but there's an extra space in program files? So you can make the direct location a completely different directory that looks like program files directory that has your scheduled tasks in it. Again, that story that you're telling people can be different. And the truth is, as an industry, as hackers, we've gotten lazy because hacking's been so damn easy. Like literally the past 15 years, I can't remember a company that I've been after that provided a substantial amount of challenge to me. Now, don't get me wrong, there's companies doing some amazing things that become much more difficult for us, but I can't remember the last time it was very difficult for me, up until, I would say, 3 years ago. We made some drastic changes over the past 3 years that have made it substantially harder for us to use commodity attacks against organizations. We never know what trip mine we're going to land on. Now there's deception out there. We have to figure out there's canary tokens, or these are weird things, or there's a specific file in there. There's all these things that we have to look at in our environment to say whether or not it's malicious or not. And it's been so easy. But again, that's changing. That's good. So my concept here is apply social engineering to hacking. Because you're going to be going after an analyst. You're going to be going after a defender that's looking for your hacking techniques. So if you can apply social engineering in the same concept that we do to hacking, we can be substantially more successful in simulating actual adversaries in our environment. And again, it's trying to trick defense. It's no different than trying to trick the end users. We're trying to trick the analysts. These attacks, in general, largely defeat software. When I talk about this, when you're trying to build a legitimate attack and you're building it into legitimate code, code that looks noisy but it isn't, it almost in every case will defeat software. I would say, as an industry, as an attacker, I'm very much a practitioner in this industry, and I very much focus on hacking, and I know hacking very well, at least I think I do. And don't get me wrong, there's a whole bunch more I can learn, a lot more smarter people than me out there. But one thing I know about hacking is that I'm rarely ever defeated by software. The software never gets me. Your latest AI and ML robots that are walking around your network trying to stop us and block us and tackle us, don't stop me and block me or tackle me. Whenever I get defeated, whenever I'm defeated as an attacker, it's from humans. It's from people. It's from getting the data to humans to be able to tell a story, not tell a story, but for them to see my story and understand that I'm an attacker in some way, shape, or form. Software doesn't stop me. People do. One thing I'll say about this type of technique is that it's not as easy as it used to be. This isn't the lazy ways that we had to hack. You know, it's interesting. I remember in this field 15 years ago, where when I had to hack into a company, I had to hack into a company. Social engineering wasn't even being talked about. Phishing wasn't even being talked about. It was like legit understanding a application flaw or finding a buffer overflow and reverse engineering a specific application, getting code execution and building that specific thing off of their platform. It was literally spending weeks and weeks and weeks and weeks figuring out a way to hack a company. And we can do the same thing today. We've gotten better at our users, but again, it takes time. Writing a book doesn't happen overnight. I wrote a book. It sucks. One of the worst experiences I've ever had in my life, especially if you go no starch. And this is a compliment to no starch, actually. It probably almost sound like a horrible thing towards no starch. No starch is probably one of the best publishers I've ever experienced in my life, but they're the worst to work with because they want their books to be perfect. And I'm glad they did this. I'm glad I went through the trials and tribulations of them because my book came out better. But man, did I hate Bill for a long time. As he'd be like, this chapter sucks. You need to rewrite the whole thing. I'm like, dude, I spent 4 weeks on this chapter. He's like, yep, it sucks. Rewrite the whole thing. I'm like, can I just change it? No, it sucks. Rewrite the whole thing. And this is what you need to rewrite it like. I'm like, okay, so writing a book sucks. But it doesn't happen overnight. And to write a good book, you have to have a good story to tell. And to write a good book, you have to know what you're doing. In order to write a good book, the reader has to believe what you're talking about. I could have wrote Metasploit the Penetration Tester's Guide, and that book could have completely sucked and I would never have sold 45,000 copies. And I was #1 in security on Amazon for 2 years. Not as like in general, like I didn't beat 50 Shades of Grey or anything like that, but in security, I was #1 for a long time on that, right? And because of the book that I told, the story that I told the viewer, they understood it and they were able to use that book to help them understand Metasploit. Same thing we can do in hacking. When we write a book, we write a story, we want the reader to believe the story that we're telling. So for defense, what can we do from a defensive perspective that makes a huge difference? Understanding multiple phases of an attack is extremely important. Hoping that these specific attacks, if I get code execution onto a system and I don't detect that because the story is believable, what happens when I do privilege escalation? What happens when I inject into LSAS if I'm doing that? That's telling a pretty bad story as an attacker. When I move laterally to other systems, if I find vulnerabilities in our systems, different phases of an attack, we have to be strong in every phase. We cannot be strong in just one. We cannot be strong in just exploitation. We cannot be strong in privilege escalation. We cannot be just strong in lateral movements. We have to be strong in every one of these phases for us to actually go and defeat what the story is being told. I'm a huge fan of what's called a balanced scorecard. If you're not familiar, there's a great talk by Chris Nickerson and Chris Gates they gave a few years ago at GrrCON. I think it was called Adversary Simulations. And one thing they talked about is how do you build a program that tracks techniques in your environment over a long span, and to be able to build and enhance on those as new ones come into. And so the balanced scorecard approach is really a great concept where you can take every phase of an attack, map that, build your detections through there, and continuously improve those to show how effective you are in those different areas. So I'm a huge fan of balanced scorecards. Great talk there. Where do we go from here? Understanding the information that goes to an analyst, I think, is really important. A focus on code execution, preventing code execution, is easier said than done. Recognizing that your tools will have an extreme amount of limitation, that your tools are not going to be the saving grace for your company, that your people are going to be your saving grace for your company. And investing in people right now in security is the most important thing that could ever happen to us. We need more people looking at things in our environment. We need more people doing things instead of burning our walls burning down. We need people to actually go and implement things in our environment. So people become the most important piece, and training of analysts become the most important piece. Looking at the full story. If I look at one story, and that story tells me it's the truth, but this story makes it false, what happens? Something's unusual. That's why I said delay that Excel one, because I don't want Excel to execute, rename, automatically kick off Registry R32. That's a behavior. If I see Excel being used, and then I see Registry R32 being used shortly after that, what's going to happen? The story I tell is probably going to get caught. But if I wait a couple hours, and it looks like it's being kicked off by the operating system, what happens? Different story I'm telling. Some basics at work, and I'm going to close it out. This is my last slide. Some basics at work. Prevention takes a long time, but there are things that we can do in prevention to make a big difference. I'm a huge fan of blocking non-code sign binaries and user profile directories. Why do regular users need to download any type of executable from the internet and have it execute in their profile directories? That stops like 80% of the noise that we see out there today. Just by using app blocker or software restriction policies or device guard, we can block non-code sign binaries from regular users. Let me ask you another question. Does Bob in sales need a full-fledged programming language at his fingertips with PowerShell? Is Bob a programmer? No. Why not disallow PowerShell for regular users and give it to your administrators and developers and everybody else? It's not going to break your updates. That's run on a system. So blocking PowerShell from regular users. Doing things in PowerShell like constrain language mode, disallow regular user PowerShell, leveraging Power 6 and above. The fact that we're still using PowerShell version 2 is horrific to me. Horrific. Please upgrade PowerShell. Leveraging something like ETW, Sysmon, for example. Olaf is a great guy and puts his heart and soul into Sysmon configuration files. And Olaf has probably one of the most comprehensive Sysmon configurations out there that maps to the MITRE ATT&CK framework and all this other great stuff. If you're not familiar with Sysmon, it's a free tool from Microsoft. It's from Mark Russinovich's team in sysinternals called Sysmon. It exposes something called ETW, which is kernel level event log tracing for Windows. And so it's a way to get better granular detections in your environment, looking for unusual patterns of behavior that you can do to offload those from your endpoints. And what's nice about endpoints, or what's challenging about endpoints, is that if you set all of your endpoint logs, every single endpoint log in your environment, directly to your SIM, what happens? You die, right? The SIM dies. The whole thing just creeps down. Your Splunk licensing goes to $500 billion a year. Your company's a $500 billion company, but they pay $500 billion for Splunk licensing, so they can't operate effectively. And so, your company dies, right? This is obviously a joke on many cases. Not the Splunk licensing, that would be like $500 billion. But with Sysmon, what's nice is that you can build configuration files to only send very specific data that you need. So you can do and/or operations. You can be like, if PowerShell.exe is ever called and it has a network connection, then send this alarm. Or if Registry R32.exe is ever called, send this alarm. Or, you can do nested commands within, that also has DNS compatibility too. So if it's hitting this DNS site or things like that, there's a lot of great things you can do with that. Disallowing things like workstation communication. Just by enabling the Windows firewall in your internal network from your workstations, what happens? You stop the spread of lateral movement from workstation to workstation. Stopping lower level protocols, like does a regular user need access to RPC and SMB? Lower level protocols. No, not in a workstation to workstation environment. For your file shares and things like that, sure. But not from a workstation perspective. Logging is so important. You do not have a monitoring and detection program if you don't have visibility into your environment. Period. And you don't have a monitoring and detection program if you don't have endpoint logs. Not all of them, but looking at your endpoints from a compromised perspective. All of these things are so important today when it comes to security. So closing up, I want to thank everybody here. Hopefully the thing that you got from this is that as an adversary, if I change my story to be something believable, and I know that I'm going to trigger an alarm, we can typically circumvent that. For defenders, you have to spend more time looking at what we're doing. There's time and time again where there's an example, there's a SOC analyst where we dropped an HTA file. And if you're not familiar with HTA files, they're called high content HTML files. It's MSHTA ends up using it, but they're very much used in malicious purposes most of the time. Most companies don't allow HTAs. This company did. What was interesting is if you Google HTA files, what are some legitimate purposes for HTA? Amazon AWS actually has a secondary method for their launcher that is an HTA file. So what do? We renamed that HTA file to the same extension type as that Amazon piece, and then we got code execution onto the system. And guess what? They Googled it. They Googled the name of that HTA file. What's the first hit that came up? Amazon Web Services. It's legit. Missed that specific indicator. However, if that analyst would have looked at the content of that HTML file, what would have happened then? Possibly a good chance we would have seen a specific attack that was happening as it was occurring. So again, the story you tell becomes really, really important, and applying the same concepts around social engineering to everything else that we do. But I want to say thank you to GrrCON for having me out here. Really appreciate it. This is GrrCON and DerbyCon and all of these other conferences, Wild West Hack and Fest. Pretty amazing thing that's happening through the community. One thing I want to mention last before I actually get off is that this week we're going to be launching probably tomorrow, either tomorrow or Saturday. We're going to be launching DerbyCon Communities, which is something that I've been working on since the last and final DerbyCon. And there's a lot to explain to this, so wait until it comes out. But it's not a competitive thing towards B-sides. What it is it's a network of community conferences like GrrCON, like Wild West Hacking Fest, like NovaCon, like AnyCon, like KernelCon, that we're all coming together to build a community of awesome networks where we can build local chapters out that don't exist. We can build other things that are happening out there. So that'll be coming out here shortly, and then hopefully see a lot of community support for this. But thanks again for having me. I really appreciate it, GrrCON, and have a good one.